With this tutorial and subsequent tutorials in the series, I will display how to set up a minimum variance frontier, pull in underlying data from an outside source, refresh the data, use a covariance matrix, and then use the solver set up this guy here and have that generate our minimum variance frontier based on the return I'm expecting to see. So let me close this out just to give you an idea real quick. Let's go here to the right. I've set this up a certain way. I'll get into why I've set it up like this to incrementally increase the expected return. I know my max return of the assets is 59. So I am going to, here this is not a formula, but it is connected, this cell is connected to an incremental option button here. What I'm going to ask it to do is give me a 50% return, which I can call on with an increment of 500. So here a 50% return, and I'm asking for the solver to give me the weights up here, the respective weights of the portfolio that will minimize the variance or the risk of a portfolio with this blend of assets that will give me a 50% return. Now the more I do this, the closer I get to a minimum efficiency frontier. Let me give you a quick example. So we've set up the solver. I'm zooming out by clicking the little Windows button left of the keyboard and then clicking a minus. I'll just do one solve, click solve at the bottom. We'll get into how to set up the solver as well. So right now it's calculating a type of blend or a mix of weights that will give me a portfolio that's producing a 50% return. So I know, here's the product of whatever I have these returns here in row 2 and whatever the solver just gave me, if I invest in Lockheed and Akamai and a few others, I will get a 50% return. So all of these here in row 2 are fixed returns based off of historical data. The solver is calculating the weights in row 1 that will then give me a return that I ask it for. And if you notice, it just did one calculation. One calculation, let me get back up here. It does give me a 50% return under 029, if you can see my cursor. But that's just one line. I need all of these lines to be able to generate a minimum variance frontier. With these tutorials, I will show you some macros where you can automate the solver to do 600 iterations, paste them under here. Then what we are going to do is copy them from the results section, go all the way down to this section and start pasting each individual result that will then help us to generate our minimum variance frontier chart. We'll get into the variance. This is what the solver is trying to minimize for. This is our variance. A lot of analysts approach it with a mode and a transpose, and what they're basically doing is grabbing this covariance section. Here's to give you an idea. I'll get into these types of formulas. The reason I've set up the formula in this way is so that, first of all, I can continue to refresh the covariance formula. And also, as I've set this up, I set it up where I can scroll down and scroll across and carry the formula, and it will still give me the appropriate result. If you notice here, I'm multiplying by 250 trade or business days. Keep that in mind. If you forget to do this, what you can do is copy 250, highlight an area, right click, paste special, and over here you can multiply by 250. I'm not going to do it. Well, you saw me copy the 250. Let me show you. So say you've made these formulas and you want 250 to copy across. Highlight where you wanted to copy to, right click, paste special, and then multiply. Click here under operation and multiply and click OK. And you'll see everything multiply by 250. Let's copy this guy again. Copy. Let's go to this piece. This incidentally is multiplying by 250, but because there's 0 here, it's not working. It's multiplying 0 by 250 equals 0. So let's do add 250. And this way you can adjust pretty much any matrix. You play around with it, it's a great feature. The next thing, we'll focus on index match. This is basically a top layer of a formula that's pulling in from a source file, and when we start adjusting the source file, say we change the mix of the assets from the source file, this will be easily able to pick up the new information. What I'm doing under here is pulling in prices, historical prices from Google Sheets for a mix of assets. In these tutorials, I'll show you how to do that. Paste them under Data tab, have the respective formulas automatically refresh. For instance, down here, I've already set this up for today, but say I haven't reactivated or refreshed the model for today from yesterday. What I'll end up creating is a macro that will highlight the last row, populate with the new information, the new delta from yesterday's price to today's price, the change. Know that there's no additional data to calc, so it will delete the last row. And something else I'd like for it to do is go under formula and create from selection from the top row. I'm going to, let me cancel this. I'm going to highlight everything. Create from selection from the top row. I'm going to want for it to create all these different ranges, and what it basically just did is create a Daimler range, a Lockheed Martin range, a Akamai range, which is then used in our matrix here, in our covariance matrix. We use the covariance matrix to calculate the variance of a portfolio. This is the long way around of calculating it. Just to give you an idea, let's say I'm doing Lockheed Martin, that's in C1. I'm pulling in the weight generated by the solver. Every single time I click solve, the weights change. Then I pull in the variance from Q6, Lockheed Martin variance. to Lockheed Martin. Every time you have a covariance like this to itself, it's actually the variance of that particular array, that particular asset. And every time we're using something like Lockheed Martin or a Daimler, and let me click Disney now, click one down, Disney to BlackRock. This is a variance of movement of historical stock price between the two, and you need this to figure out how they move together or against each other so that we can calculate the risk or the way that they move together or opposite from each other to get a sense of what this variance around the individual averages is, and that's how we measure portfolio risk. Because we have such a large amount of data generated by the solver and necessary for us to be able to capture a minimum variance frontier, I will then get into a ranking system so that once we plot the minimum variance frontier, and the way that's done is up here, the insert, and over here we have a scatter plot. Once we plot the minimum variance frontier, we have our data points here, our data labels. We'll begin with something like this. As I go along, if I need corrections, please leave me comments. If you have any questions, let me know, and I hope that this is helpful, that I can learn from you and you can learn from me.